Workbook 3, question 10. Trapezoid ABCD has vertices at A, -3, -2, B, 0, 3, C, 6, 5, and D, 9, 2. The point L is located at the base of AD with approximate coordinates of 7.2 and 1.4, so that CL is the height of the trapezoid. Okay, so that's important to know. That is our height. We do need to have that. So match each question with the correct measurement rounded to one decimal place. All right, the approximate length of CL. All right, so we want a length here for CL. They want the area of the trapezoid. We need a couple of information, and I wrote it A with trap in tiny script just so I know that it's the area of the trapezoid. And then what is the approximate length of AD? Okay, so we need to know AD and we need to know BC. Okay, here we go. And I believe all of these are the steps that we need, the information we need for our area. So let's go through and find the distance for CL. Now the distance of CL is going to be the horizontal distance, and since L has approximate coordinates, I'm going to find the distance algebraically. I'm not going to count it out. So we're going to find our horizontal distance from C to L. So I'm going to start with with L's x coordinate, so 7.2. I'm going to subtract C's x coordinate, 6, and that'll give us our horizontal distance, this distance right here, the horizontal distance from C to L, plus, and now I need our vertical distance, so this way from C to L, and I'm going to use L's y coordinate because vertical is the y-axis, and we're just finding a distance, so we're finding the difference between these two locations. So 1.4 minus 5 squared. Okay, and then we will equals the square root of, now I will come over here and ask for a calculator. And I will type in 7.2 minus 6. That's going to give us 1.2, and it is squared, so I'm going to hit this x to the y and square it right now. So that's 1.44. That's a 4. Plus, okay, and now we're going to do 1.4 minus 5. So 1.4 minus 5, and it gives us negative 3.6, and this is squared. So now with something being negative, we have to make sure that it has parentheses. So I'm just going to retype it, negative 3.6, and I'm going to square it. So anytime you square a negative number, please make sure you're typing it in the parentheses before you hit this x to the y and squaring it. If you forget that, it will give you, let's just show you. So if we forget the negative and we just said negative 3.6, and I hit this x to the y and I square it, if you notice, it gives us the same numbers, 12.96, but it's negative, and that's because it is squaring 3.6 first and then multiplying it by a negative at the end, instead of multiplying negative 3.6 times negative 3.6. So parentheses are important. And then we're going to keep this up and we're going to just say what's 1.44 plus 12.96. 1.44 plus 12.96, which equals 14.4. And I'm going to delete this since they're giving it to us. And that's going to equal the square root of 14.4. So then we're going to do the square root of 14.4. 3.79, which is approximately 3.79. Okay, so now let's come back to our course player. And I'm looking for 3.79, but they want it rounded to the 1 decimal place. So I'm going to look at the hundredths place, and that's a 9. So that means that this is closer to 3.8 than it is to 3.7. I think of it, okay, is 79 closer to 80 or closer to 70? Well, 79 is closer to 80, so this should be written as 3.80, and we really don't need the 0. But that's how I remember rounding. So when I click on the approximate length of CL, it is 3.8 units. All right, there we go. Moving on to the next one, we need to find AD's distance, and now I like this one because I can count this out. I don't have to use the approximate, and I don't have to algebraically write out my distance in order to find it. I can count it. So we're going to do the same thing. We're going to find our horizontal distance by counting it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So our horizontal distance is 12 squared plus, and our vertical distance is 1, 2, 3, 4. Since I went up, it's positive. Okay, so then we're going to come back here to our calculator, and 12x to the y squared, 144. So this is going to equal the square root of 144 plus, and I know that 4 squared right off my head is 16, so I'm just gonna just take 144 and add it to 16, and that equals 160. So this is going to equal the square root of 160, and so then I'm going to type in our calculator. What is the square root of 160? And that is approximately 12.64, and so they wanted it rounded to the nearest tenth. So I think to myself, is 64 closer to 60 or 70? And 64 is closer to 60, so it's going to be 12.60, and we really don't write the 0, so it's 12.6. Okay, so then we're going to come over here and we're going to click on AD's approximate length is 12.6 units. Alright, so now we have BC, and BC's length is going to equal, I'm going to write it down here, BC is going to equal the square root, again, of our horizontal distance, which we can find by counting. So we're going to count horizontally 1, 2, 3, 4, 5, 6. So it's our horizontal distance squared plus our vertical distance, and we can count that as well. 1, 2 squared. So that equals the square root of, and you can do the same process with the calculator. I'm just going to do this it's quicker for me to talk it out instead of typing it on the calculator. So we have 6 squared is 36, and 2 squared is 4, and we have the square root of what's 36 plus 4, that's 40. So then in my calculator, I'm going to type in what is the square root of 40, and that's going to equal 6.32. They want it rounded to the nearest tenth, so I'm going to ask myself, is 32 closer to 30 or to 40? 32 is closer to 30, so then I know that this is approximately 6.30 or 6.3, because zeros do not change the value, so 6.3. And then it wants to know what is the approximate area of the trapezoid. Okay, well, I'm pretty sure we found all of our pieces, and if you don't have the formula for the area of a trapezoid written in your notes, it's a good reference if you look through all of these perimeters and areas of polygons. That's where I would check first. So we're going to click that. Perimeter of a parallelogram, keep going. Perimeter of a rectangle, perimeter of a square. What about a trapezoid? Okay, there's the area, perimeter and area. So if you do not have these written down, I would write them down in your notes, and that way it's a quicker reference for you. So that's how I would look up the information if I did not have it. So it would be area is 1/2 times our height times our base 1 plus our base 2. And now they had us fill in our bases. It said that AD was a base right there, so I'm gonna just label that as base 1, and our height connects our two bases, so I know that this is base 2, because the height goes from one base to the next. And so we have everything we need in order to fill out our area. So we're going to have the area of a trapezoid is equal to 1/2, and I'm going to put that in parentheses, times, they are connected by, everything is connected by multiplication right here. So 1/2 times our height, and our height was CL, so 3.8, times base 1, which was AD, 12.6, and it says plus base 2, so plus BC, 6.3, and that's what I'm going to type in my calculator to find my area. So then I'm clearing this, I'm making sure I have my parentheses. 1/2 is 1 divided by 2, times, parentheses, 3.8, times 12.6 plus 6.3. That's going to equal 35.91. Okay, so then they still want it rounded to the nearest tenth. So I'm going to ask myself, okay, is 91 closer to 90 or 100? And 91 is closer to 90, so we're going to have 35.9. So that's approximately equal to 35.9, and it is units squared. Area is always going to be in square units. So approximate area of a trapezoid is 35. Oh, I see what they did here. This is 35.8 units squared, or 36.0 units squared. 3.8, 12.6, 6.3. 35.9. I am assuming that they did not round it when they multiplied these all out, so they left it as like they didn't round correctly. So let's check this, 36.0 units, and let's just check it. All right, good job. So for some reason there is a rounding error, and I believe it's because when they found it out, instead of typing 3.8, they kept it at the square root of 1.44 and the square root of 160 and the square root of 40. So I think there was an error there on their rounding. So there's question 10. Let's move on to question 9. Short fill-in. Parallelogram EFGH has vertices at E13, F02, G40, and H51. The area of the parallelogram is blank units. Enter your answer as a number rounded to one decimal place if necessary, like this. Okay, parallelograms are rectangles, and so I know that the area of a parallelogram is going to equal our base times our height. So let us double check that if you want. And so you would go down here, area of a parallelogram, it is our base times our height. Now if you notice, the height is not one of the side lengths because it is because the side length is on an angle. It's not the true height of the parallelogram. So when we come down here to our question 9, right here, enter your answer as a number rounded to one decimal unit. We need to know the height, or this distance right here. So if we are to do that, oh, nope, that's H. Okay. So let's first find the length of one of our bases, and it's going to be FG. So I'm going to find the height, the distance of FG, and that's going to equal our horizontal distance and squared plus our vertical the square root of our horizontal distance plus our vertical distance. So our horizontal distance is 1, 2, 3, 4. So that is 4 squared. Plus our vertical distance is 1, 2. And it's negative since I went down, so I'm going to have negative 2 squared. That's going to equal the square root of 4 squared is 16 plus negative 2 squared. Remember to include your parentheses when you're typing it into your calculator. And negative 2 times negative 2 is 4. 16, we're going to end up with the square root of 16 plus 4, and 16 plus 4 is 20. So then what is our approximate for the square root of 20? I'm going to come over here, the square root of 20. That's going to equal 4.47. So now we need to find our height of it. And the height of this, I'm going to look for I know the height has to be at a 90 degree to the base. And so we're going to I'm going to use these 2 points. Okay, so this point, it is 2, 1, and this point is 3, 2. So we're going to find our height algebraically now, and it's still going to be our horizontal distance, which is our y coordinates. So 2 minus 3 squared plus our vertical height, which is our y coordinates, so 1 minus 2. And that's going to equal the square root. 2 minus 3 is -1. That's going to be squared, plus 1 minus 2 is going to be -1 squared. So that's going to equal the square root of -1 squared is 1 plus -1 squared is 1. Remember to include your parentheses first when you type it into the calculator. So we're going to have the square root of 2, which is approximately, I want to say like 1.7. Square root of 2, 1.4. Alright, I was off. 1.41. So now we're going to come back here and we're going to type in, we need the area of a parallelogram. So base times height. So our base's distance was 4.47 times 1.41, and I'm going to save the rounding to the end. So then we're going to come here, 1.41 times 4.47. That's 6.30. They want it rounded to the nearest tenth. So is 30 closer to 30 or closer to 40? And it's closer to 30. So we have 6.3 units squared. 6.3. So let's check that. Great job. Alrighty. And we're going to move in to question 12 is very similar to question 8 is very similar to question 10, where you would have to find the height using its coordinates and then find the distance of AB since it's the base, and then use your triangle formula. Okay, so now we have, I'm going to do question 7. Square ABCD has vertices at A -1 3, B 0 7, C 4 6, and D 3 2. What is the perimeter of the square? Okay, so we're going to find the perimeter of a square is with all of the sides added up. And now I know a square has all of the same sides. So perimeter of the square is going to equal all of my sides added up. All of the sides are the same, so it's 4 times my side length, or you could write it as perimeter of the square is equal to side plus side plus side plus side. Because all of the sides are the same, I'm only going to find one side distance and then type it into our equation. So let's find BC. And I'm going to count it out because that's faster for me than to write it in the distance formula. It's the same process. The distance formula is the square root of the horizontal distance. So 1, 2, 3, 4, and it's positive because I went to the right, squared, plus our vertical distance, which is -1 since I went down. So distance formula, square root of the horizontal distance plus squared plus the vertical distance squared. So then we have the square root of 4 squared is 16 plus -1 squared is 1. Square root of 16 plus 1 is the square root of 17. So I'm going to come over here and I'm going to type in what is the square root of 17. That's going to equal approximately 4.12. We're going to say rounding to the end. I think that's what threw us off in question 10, is because we multiplied out with the rounded numbers and we didn't save rounding to the end when we did our area. So save rounding to the end. So then we're going to come back here with our perimeter of our square, and that's going to equal 4 times 4.12, which is going to be approximately, and I'm just going to hit 4.12 times 4, that's 16.48, and it wants it rounded to the nearest tenth. So I'm going to ask myself, well, is 48 closer to 40 or closer to 50? And it is closer to 50, so I'm going to write this as approximately 16.550. So, and the 0 doesn't add a value, so we often do not write it. So then we're going to write this in as 16.5 at 0.5, and we'll check it, submit for grading. Great job. All right, and there's your workbook help. If you have more questions, please feel free to email me, fill out my help form, or attend the live office hours.